Acceleration. So what happens when we change velocity? The focus of this lecture is to introduce the ideas or the concepts of acceleration and to calculate given changes in an object's velocity. So far up until this point, we've been talking about things at constant velocity, where the velocity does not change. Like, for example, when things are at rest or moving at one particular velocity the whole time. For example, 1 meter per second, 1 meter per second, 1 meter per second. But what happens if the velocity changes? This is what we call acceleration. Acceleration is denoted by this A to represent acceleration and is in the units meters per second squared. And it's the square that gives you the indication that we're talking about an acceleration. Meters per second is a velocity. Meters per second squared is an acceleration. An acceleration is how velocity changes over a particular amount of time. Now, there are three possibilities, really. Three. The first one is something speeds up. We call this positive acceleration. In other words, going from a slow velocity to a fast velocity. That's speeding up, and we call it positive acceleration. The second option is the object slows down. And this is negative acceleration, or deceleration. And that's a condition from where you're going from a fast velocity to a slow velocity. And really, if you think about these two things, cars have two pedals that do these things for you. Is there a pedal that speeds you up? Is that the gas pedal, known as the accelerator? Is there a pedal that slows you down, known as the brake pedal or the decelerator? The third possibility is actually changing directions, and this is turningness. And so in your car, you have a steering wheel, and when you turn it, the car turns as well. This is a really special circumstance in physics that we don't play with too much in my class. One thing that students tend to have difficulties with is if an object is moving at a constant velocity, then we say that the acceleration is 0 meters per second squared. So for example, if an object is at rest and it has 0 velocity, and then sometimes later it has still a 0 velocity, it is not speeding up, it is not slowing down, and it is not changing directions. If it's 1 meter per second, 1 meter per second, 1 meter per second, it is not speeding up, it is not slowing down, and it has 0 meters per second squared for the acceleration. Okay, acceleration. How do we calculate it? So here is the formula for acceleration. A equals open parenthesis VF minus VI close parenthesis divided by T. And it looks kind of scary, but if I use more words, I can say that acceleration equals the velocity at point B minus the velocity at point A divided by the time it takes to go from A to B. So let's define some of these letters here. A stands for acceleration. This VF stands for velocity final, or the ending velocity, minus VI, which stands for velocity initial. And this is the beginning velocity. Initial means beginning. And T stands for the time it takes to go from the initial velocity to the final velocity. And then finally, once again, the units is meters per second squared. And the squared is really important. So let's take a look at this in practice. So, I have a crate that is paused here, but in the very beginning it is traveling at 28.3 meters per second. Now it's paused at the moment, but this 28.3 meters per second is a velocity initial. What happens if I let the movie play? I see that the velocity starts to go down or decelerate. And the time it takes to go from that initial velocity to a final velocity of 4.7 meters per second helps me figure out acceleration. So if I need to figure out the acceleration or deceleration of the crate, I can use the guess technique. Let's gather some information in the beginning. So my velocity initial of the crate was 28.3 meters per second. And then I hit the start button, and I allowed the crate to start moving. And we noticed that the crate's velocity got slower and slower and slower. But we notice that it took a time of 12.524 seconds before we had a velocity at the end, or the velocity final, to be 4.7 meters per second. The thing that we're looking for is acceleration. We don't know that number, but we know that it is in meters per second squared. And the equation that we just learned was acceleration equals velocity final minus velocity initial divided by time. So now if I replace numbers for letters, I don't know what acceleration is. But I do know that it equals my velocity final, which is 4.7 seconds, minus my initial velocity, which was 28.3 meters per second. But I know that my time is 12.524 seconds. So these parentheses tell me that I want to solve the top of the numerator first. And so when I get out my handy dandy calculator, I can take 4.7 minus 28.3. And I get a result of negative 23.7 0.6 divided by 12.524. Now I can use my handy-dandy calculator to solve everything in the yellow circle. And when I complete that calculation, I get acceleration equals negative 1.8844. But I need to include units, but it's right here, meters per second squared. Now that's great and all that we've actually calculated a number, but what does it actually mean? The fact is, because it's negative, it tells me that it's slowing down, or also known as decelerating. And what it tells me is that for every second that goes by, the velocity goes down 1.88 meters per second.